In the last video, I talked about and showed the derivation of the difference quotient, and today I'm just going to show you how to use it. So I've got a few examples lined up. So the first example is f of x equals to x squared plus 2x. Find basically the derivative function. So pause the video and see if you can figure this out using this difference quotient formula. All right, so the way we do it is we first write f prime of x is equal to the limit of h approaching 0. And basically all you're really going to do is you're just following, again, this formula. You're just using this formula. So for every x value, we're going to plug in an x plus h for the first part. So let's do that. So we have an x squared here. So we're plugging in an x plus h into x squared. So that's x plus h squared, right? Plus 2, because in every x value, we're going to plug in x plus h first. X plus h minus just simply f of x. And in this case, f of x is just x squared plus 2x. All of this, oops, not a very straight line, all of this over h. So as we progress, the limit of h approaching 0, now we're just going to expand the x plus h squared term. So that's just x squared plus 2xh plus h squared, plus we're going to expand this and this now, 2x plus 2h, oops, and I forgot to put a bracket here, apologies, minus x squared minus 2x, because we carry the negative to both of them, apply it to both, all over h. So you can see it gets very nice and repetitive with you writing limit all the time, but you have to do that. You can't write limit once and then not write it again, because then you're saying, oh, there is no limit here. So you have to keep writing limit. Now we just do some, basic canceling out, see what we can do and all that. We can see that, well, there's an x squared here, and there's an x squared here. That's x squared minus x squared, so they cancel out. We have a 2x minus it, so we have a 2x here and a negative 2x here, so these just cancel out. And what we're left with is simply h squared plus 2xh. I'll highlight it. That's what we're left with. So h squared plus 2xh plus 2h all over that. And then now you might be able to see something here is that, well, all of them have h, so we can actually do a little canceling out. So we can actually just cancel out this, 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 and that becomes a 1. So that's h plus 2x plus 2. Put the bracket around it because the limit is applying to the whole thing. And now we can just substitute. We can just plug in 0. The reason we didn't plug in 0 before was then our denominator would be 0. And then, well, you can't really do much once you have that. So really what you're going to notice is we're just trying to find a way to get rid of this denominator and to express it in such a way that, well, we don't have an undefined situation. So we just plug in 0 for h as if it was, 0. So you get 0 plus 2x plus 2, and then you're just left with 2x plus 2. And that's it. That's the derivative function of this one. Let's try another example. Let's say let's do a rational function. Let's say we had f of x equaling x over x minus 1. Pause the video and see if you can try this. It's a little trickier. So basically, if we remember our limit formula correctly, and I can try to write it here, f prime of x equals to the limit of h approaching 0 of f of x plus h minus f of x all over h, right? So we're going to apply that here now. So the f prime of x equals to the limit of h approaching 0. Now, for every x value, we're going to plug in x plus h. So here it gets a little tricky. So I'm going to plug in first into this top guy and then this bottom guy. So that's x plus h over x plus h minus 1. Minus, now, because minus, there's a minus here, f of x. So now we just write f of x, x over x minus 1. This is really important to note. Notice how these are two separate fractions. They're not the same thing. You might be tempted to write this as, you know, x plus h minus x, and then the bottom is x plus h minus 1. That would be wrong. And the reason is you're plugging in x plus h first, and then you're plugging in f of x after the subtraction. So they become two separate fractions all over h. That's how it works. So now what we do is, well, we're going to write the same thing we always write, the limit as h approaches 0. Now here we basically just do some simple math, and simple is because we just want the same denominator for this and this term, you know, this whole term right here. So all we're going to do is multiply each thing to make sure they have the same denominator. So we see that there's an x plus h minus 1 and there's an x minus 1. So I can multiply this whole thing by x minus 1, and I can multiply this whole thing with x plus h minus 1. So with that said, this would be x plus h, x minus 1, minus x, then x plus h minus 1, all over x plus h minus 1, x minus 1. And since we have a fraction over something we're dividing, the h just goes here because the h is technically multiplying these two terms because they're both, you know, below, they're both like the denominators. And then the limit as h approaches 0. Now we just basically expand. So we have x squared. So I'm expanding, let me do this in a different color. I'm expanding this right here. So we have x squared minus x plus h of x minus h. And then we have minus, I think, x, yeah, okay, we're good. Then I'm expanding, let's do this guy over here. So then you get x squared minus, because there's a negative sign here, we have to watch out for. So we have to include that. We have x squared, negative x squared, minus xh plus x, because that's a minus 1 times a negative x, all over this lovely denominator. And so, like we did in that previous example, now we're just going to try to simplify. Our x squareds here cancel out. Our x's cancel out. Our h of x and xh, that's just the same thing, they cancel out. So all you're left with is now is a negative h. Yikes, that's huge. Hold up. Negative h all over h, x plus h minus 1, x minus 1. Now we can just do some canceling out here with our h terms. So the limit of h approaching 0, these guys cancel out. You get negative 1 over x plus h minus 1, x minus 1. And now we just plug in 0 for h. So that leaves us with x minus 1 times x minus 1 over negative 1, which is just negative 1, or I can just say 1 over x minus 1 squared. Negative 1 over x minus 1 squared. And we're done. That is the derivative function. Let's do one more example. Let's say we had f of x equaling to root 2x. Pause the video and see if you can sort of try this out. So again, I'll write the formula again. This is f prime of x equals to the limit of h approaches 0 of f of x plus h minus f of x over h. So same thing, we're gonna just plug stuff in. So first we're gonna plug in the x plus h bars, or actually before we do that, we write the limit of h approaching 0. Now we write it all. So basically that's 2, and then for every x value we're gonna put in x plus h first, x plus h, like this, so minus f of x, which is just root 2x over h. And then we write the limit of h approaching 0. Now I showed this strategy in the last video. It's instead of let's say you had a radical in the denominator and then you rationalize, now we're going to work backwards. So we're going to make the denominator have a radical. So the way we do that is we see that there is, in this term, there's a minus sign. So all we have to do is actually multiply it by the same thing, but in between the root 2x plus h and the root 2x, there's going to be a plus sign. So here's what it's going to look like. 2x plus h, all under this radical, minus root 2x, multiplying 2x plus h, plus, that's where the sign comes from, all over h, and then 2x plus h plus 2x. So h multiplying this, because we have, if we, whatever we put in the numerator, we have to put in the denominator to make sure it's still staying the same. All right, and now this is just a difference of squares kind of thing. So this is like, let me do that in a different color. This is just like a, b plus minus being multiplied by each other. So that would give you a squared minus b squared. So in this case, this will be 2 x, or actually, yeah, let me just do it like this. 2x plus h minus 2x over this and now we can just expand the limit of h approaching 0, 2x, so 2 times x and then 2 times h. We know that if we multiply this by a 2x, there's a negative 2x waiting there, so those two would just cancel out, the 2x, the negative 2x, and then we just get 2h over h, and then we get 2x plus h plus 2x. Once again, our h can cancel out both on the top and the bottom. So we get the limit of h approaching 0, 2 over 2x plus h plus 2x. And now we can just plug in 0 as if it equaled that. So that would be, so 2x plus 0 plus root 2x over 2. And I'm just doing one step at a time because I don't want to confuse anyone. Otherwise, for some people I may be going too slow, but I'm doing that on purpose. All right, anyways, so that 0, that doesn't matter because 2 times 0 is nothing. So we can just ignore that. Then you get 2 over, we have one root 2x here and another root 2x here, so that becomes 2 root 2x, and then this just simplifies because this 2's cancel out, 1 over root 2x. So yeah, that was basically just some examples I did, how to use the difference quotient. I did not sub any values for x, just so I could show you the general derivative function, the thing I was talking about in the last video. Hopefully this helped. Let me know in the comments if you want any specific examples. I can maybe throw it in a future video. And yeah, that's pretty much it.